Hey guys, what's up? Today I'm gonna talk about how to be data engineer 2024. So here's the GitHub report, which shows the roadmap, and I'm gonna add my comment as our experienced data engineer slash data science master's degree student, our ex-student. Um, my point of view, after working as the master's degree around 2 years and work as startup, and then now working in one of the biggest enterprise, especially some cloud services, um, to be a data engineer. So let's go. This diagram explaining, starting from the CS fundamentals. I do agree with this. It breaks down into these components. Indeed, to start with, it is nice to have the strong foundation, and terminals are essential basically. Whether you work as the data engineer, I believe this is as a software engineer, the skills such as bash script and simple commands, cd and pwd, current working directly, and how to touch or make DL and make a file, and nano write a script, move on to the your link, and once you get used to it, probably you're gonna use it as some of the variables, so they export your variables and things like that. Those are critical in any working environment, so it's nice to have. Data structure algorithm, I would say yes. If you're the one who write the code, this part are very important. Like a binary sort, probably you might see a lot of like heap, so that's analog and time complexity, which is basically that's how you learn the algorithm and structure. But I more emphasize on the APIs and the data itself. So those points are more important. So API is how basically you connect the interface of your software. If you have the microservice architecture, probably you need to be aware which API is sent, and to the server side how the API are received and send back the request as a response. And the data side, you have the structure and structured data. If it's structured data, even if it's structured data, there are different ways to process the data. Unstructured data probably have the a lot of different SQL, NoSQL, things like that, which I'm gonna explain further details later. These are Linux is a part of the basic terminal you can relate. And math and statistic, this could be later probably the priority for now. The JIT is a good to know, but not necessary if you are not directly writing the code. I mean, the version control skills are nice to have, but you might have something different priority as a data engineer. And for the programming language itself, I would say it really depends, but the first two are pretty commonly used. And what I feel myself is Java is particularly useful for the data structure because it has very high efficiency for processing the data. Let's say some major code like Apache and Kafka, um, um, some product like GCP support the Java client, so you're more easy to start and actually work on the project once you get the concept of Java. And I have some friends who can write Java and then start writing the code in Python. This transition is much easier. This is because Java has, in the way, the lower level of the API, which means you have a lot more thing to define when you write the code, which might not be necessarily aware or pay attention during the Python programming. So moving on, there's the testing. Well, it's something that you wanna definitely understand. There's a different level. Maybe you see there's some kind of triangle, and unit tests and functional testing, and then integration testing, and finally the functional testing. And I would add the a load test. That's when you have some retail or any kind of peak time, you could test that. If it's Python, there's a library called locast. and check the QPS and so on. So it will be one of the category here. And here comes the database. As I mentioned, there's SQL and then the NoSQL, which can be used for the unstructured data, ASCID transactions, normalization. Those are like some terms. There is the OLTP concept. Yes, basically OLTP or AP. So either this is transaction database. So if it's the Pareto, probably the TP is 20%, 80% write and 20% read. While the OLAP, you might have the higher priority for the writing and actually the reading the data for the analytics purpose. So that will be like a BigQuery or the Redshift in the AWS services. Yes, the scaling it's a very important. You might want to be aware what's the horizontal scale and what the difference and the actual use case. And some situation vertical scaling itself can be useful. That's it depends on what kind of microservices you're using. Relational database is the same concept and part of the database, and MySQL, PostgreSQL. I personally don't really point out which database is good or bad. Essentially, it doesn't really matter as long as you can process the your main business operations. So application server need to process the data. So choose the one that suits your needs. And non-relational database, you don't have to go deep here, gang. Essentially, you will pick what's most suitable. I personally like Redis. For example, right now there's the retrieval augmented generation, which is part of the generative model processing in the enterprise search. And for that, you can use, for example, the Redis to store the vectors. You can use it as a vector database in a way. Some of the database are actually interchangeable, but might get to know some of those names, like what the big table and things like that. And the data warehouse, there are a lot of them again. But this is one that is used analytics. So you can think of it as to process or analyze the data. And those are data is finally routed to the dashboard. So Looker dashboard, probably the some dashboard, real-time analysis. But finally, you will use to process and serve the data. And that's strange, as you can imagine, where the data is stored. So it's part of the data lake, what you can call. And the cluster computing is also important. When you scale the data, you need to have the multiple instances to process. So that's parallel processing. If it's the Python, there are frameworks such as the Dask or the Ray. You can use the PySpark, and the concept counts the map reduce and HDF file system and how the Hadoop, let's say, master and child node works. And it is very, very nice to have. This is because a lot of the data is scaled up eventually, and this is where the central processing work. So personally, instead of learning multiple language, if you can write the SQL, that's mostly used within the whatever the processing. It is quite powerful. You just remember the basic syntax, and it's better to have the ability to debug this cluster computing. So not only just concept, but actually using them. And the following also related: batch and streaming. Mainly the batch process can be kind of cluster computing. It processes the data in the batch, so it's usually non real-time application, while the streaming is more real-time application where you might use the asynchronous processing. So you process the data and once you're live, and you can process the let's say that if there is a message queue, so that's a whole topic you receive from each publisher, and you will get the data from a subscriber. So the data, the message can be processed let's say if you're using some of the sliding window or kind of concept, you can batch up while it's streaming. So it's good to know which part applies and adjust accordingly. Apache Airflow is quite powerful. Not necessarily, but if the enterprise is looking for a solution, the scheduling workflow, this can be replaced. Let's say like cron job or something more simple. But Airflow can do the more massive scale processing as it can run on the distributed computing. So it's nice to have, and also you can run a lot about parallelization, auto scaling. If this run on the Cloud Composer, I mean that's a GCP service or something similar to the AWS. And log, well, you need services, but those are quite important. And networking, it's also very important what the protocol. So this is each layer of the your network connection and firewalls and VPN, how the VPC works. These are very important, especially your data is processed with the network, so you need to have certain bandwidth to process the data. If the network, let's say some port is exhausted in your compute instance, you might face the errors and your connection channels close and your packet drop, which means the data is not processed. So those are very core knowledge that I emphasize. Infrastructure code, I only mentioned about Terraform here, but it's nice to have. And I would say the content orchestration, it could be a more infrastructure engineer, but it's nice to have like how the pod and node are different and where the IP address is assigned within the GKE or Kubernetes in general, and how to basically store the data within the node. And these are topic and beyond. CI/CD is nice to have. Visualization is mostly the analytics side, and machine learning, it's nice to have a bit, but not necessary. You might just know what the AutoML, and actually if it's the GCP, they have something called the BQML, which is the machine learning, but in the SQL, and use a BigQuery. So that application is, in my opinion, very useful, as machine learning part are very tiny, as the some white paper suggests already. Real technical debt comes from the something more data engineering work, such as logging and the debugging and traceback, everything that basically gives the error in your system. So you don't have to go deep here, but I suggest how to debug each layer of the application, and especially the network and storage and compute. So those three pillars are very essential to get familiarized as a data engineer. So to summarize this roadmap and my opinion, I think it's a pretty nice roadmap described here. It is overwhelming at the beginning, but eventually you will get used to it and figure out what is a higher priority in your work, in your career, and where to apply and what should learn next. So not necessarily this map is aligned with your actual learning progress, but I suggest to adjust based on your situation and pick up the higher priority. As my career to repeat, I emphasize to learn what the basic data, so the focusing on the data, how to process the data, and especially when you build a system, how to debug and get a traceback, while being aware how the network work to connect from, let's say, one node to the other node, because essentially that's most of the work as a data engineer comes from. All right, thanks everyone. So that's a recap for 2024, how to be a data engineer, and I will see you next time.